Dear students, now I want to discuss octet rule from chemical bonding and molecular structure lesson. Cossel and Lewis in 1916 they developed an important theory of chemical combination between atoms known as electronic theory of chemical bonding. So according to this theory or according to this rule, atoms can combine either by transfer of valence electrons from one atom to another, means by gaining or losing, or by sharing of valence electrons in order to have an octet in their valence shells. This is simply known as octet rule. Clear? By gaining or losing, or by sharing. So atoms in their valence shell, if there are 8 electrons, then simply those molecules obey octet rule. They are simply stable. Understood? So this is octet rule. Clear? Any central atom, it is surrounding by 8 electrons. 8 electrons. So that is simply known as octet. Clear? Those molecules are stable. Understood? Now, some examples. Cl2 molecule. Is it obey octet rule or not? Chlorine, group number 17th or 7th A. So 7 valence electrons are there. So valency electrons is equal to 2 into 7. Chlorine group number 7 valence electrons. Total how many? 14 electrons. Clear? 14 valence electrons. Now chlorine. How many electrons? 7 valence electrons. 7 valence electrons. Now another chlorine. How many valence electrons? 7 valence electrons. So 7 valence electrons. Now chlorine 6 electrons, we can write like this is this chlorine electron. Now coming to adjacent chlorine, it's 7 electrons, 3 lone pairs and its single electron. Clear? Now around the chlorine, how many electrons? 8 electrons. So around this chlorine atom, how many electrons? 8 electrons. So both atoms obey octet rule. Both atoms obey octet rule. So according to octet theory, it is more stable. Cl2 molecule is more stable. Understood? So simply we can write Cl single bond Cl. Here 3 lone pairs and here 3 lone pairs. So Cl2 molecule in which both chlorine atoms obey octet rule, so it is more stable. Now moving to next example. Example 2. Carbon monoxide molecule. Carbon monoxide molecule. Valence electrons 1 into carbon group number 14th A, 14th or 4th A. 14th or 4th A. So 4 valence electrons, 1 into 4, plus oxygen group number 16th or 6th A, 6 valence electrons. So total 10 valency electrons. Clear? 10 valency electrons. Very, very important example it is. Now carbon group number 14th or 4th A, 4 valence electrons. Oxygen group number 16th or 6th A, 6 valence electrons. So now carbon 4 valence electrons, oxygen 6 valence electrons. Now just observe, around the carbon how many electrons are there? 6 electrons. But around the oxygen how many electrons are there? 8 electrons. Oxygen obeys octet rule, but carbon does not. That's why here lone pair is there now. So this lone pair, here just observe, this lone pair, okay, here lone pair is there now. This lone pair, if it donate to carbon, this lone pair, if it donate to carbon, then carbon also obey octet rule. So now carbon, oxygen, here two electron pairs can form one double bond. This electron pair and this electron pair we can write like here carbon electrons and oxygen electrons. Okay, so here this lone pair donate to carbon. For obeying octet rule, that lone pair donate to carbon. Now carbon, oxygen. Now this lone pair donating to carbon. Understood? Now we can write dative bond. Now we can write dative bond. Understood or not? Oxygen donor, carbon acceptor. Oxygen donor, carbon acceptor. Understood? That's why donor, in between donor atom and acceptor atom, one bond is formed, that is dative bond. Coordinate covalent bond. What is the bond? Dative bond or coordinate covalent bond. Understood? This is dative bond or coordinate covalent bond. Sometimes we can expect one question. In carbon monoxide molecule, how many dative bonds existed? One dative bond. One coordinate covalent bond existed. Very, very important. Okay. So otherwise, in another way, we can expect one question. In which of the following molecule dative bond existed? For example, carbon monoxide is there one of the options? Yes, carbon monoxide is the right answer. So now just observe around the, here just observe, around the carbon how many electrons? Even dative bond also one bond pair we can consider. 3 bonds, 3 to the 6 plus 1 lone pair, 8 electrons. Yes, carbon obeying octet rule. Similarly, this one also 3 bond pairs, 1 lone pair, 8 electrons. Yes, it obey octet rule. Clear everyone? Yes. Now coming to example 3. Example 3. NO2 minus ion. NO2 minus ion. Now valency electrons. Nitrogen group number 50A or 15th, 5 valence electrons plus 2 into oxygen group number 16th or 60A, 6 valence electrons. 1 negative means plus 1. Now here 2 6 is 12 plus 1, 13, 13 plus 5, 18 electrons, 18 valence electrons. Now first you can write skeleton structure. Skeleton, nitrogen, oxygen, oxygen. You know oxygen group number 6, oxygen group number 6. 6 electrons you can write. And this oxygen group number 6 only. We can write like 6 electrons. Okay. Nitrogen group number 5th, 5 electrons we can write. 5 electrons we can write. We can write like, yes, we can write like 5 electrons. So clear? We can write like. Now here one negative charge is there na. Negative charge we can write Yes, one extra electron. For negative charge, we can write one extra electron. Yes, negative charge. Understood? So now here, this is a Lewis dot structure. Now oxygen, this bond, we can write like bond nitrogen, 4 electrons means double bond, 4 electrons means one double bond, oxygen lone pair. Here negative charge, yes. So now, is it obeying octet rule or not? Once verify. Around the oxygen, 3 lone pairs, 1 bond pair. Total how many electrons? 8 electrons. Around the oxygen, 2 lone pairs, 2 bond pairs, 8 electrons. Similarly, observe this one, 3 bond pairs, 3 to the 6 plus 1 lone pair, yes, 8 electrons. So, all atoms obey octet rule. So, this is stable molecule only, stable ion. Understood everyone? Yes. So, these are the some examples. Now, limitations of octet rule. Okay, now octet rule definition and few examples we have completed. Now, limitations of octet rule. Limitations of octet rule. Limitations of octet rule. So the octet rule, though useful, is not universal. It is quite useful for understanding the structures of most of the organic compounds. And particularly it applies mainly to the second period elements of the periodic table. So second period elements, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine. Yeah. Second period elements, mostly it is applicable to second period elements. Okay. There are particularly 3 types of exceptions. There are particularly 3 types of exceptions to the octet rule. Okay. Simply, they are not obeying octet rule. Okay. Now, I am saying, I am explaining 3 exceptions. So, these 3 exceptions, actually these 3 models, they are not obeying octet rule, even though they are stable. That's why these are limitations. Okay, exceptions are limitations. Understood? So now, so generally they are stable, but they are not obeying octet rule. That's why these are the limitations or exceptions. Clear? So now, first one. First one, incomplete octet of the central atom. Incomplete octet of the central atom are simply deficient molecules. Okay, electron deficient molecules. So incomplete octet. Incomplete octet means around the central atom less than 8 electrons are present. Less than 8 electrons are there. So they are incomplete octet molecules. Okay, around the central atom less than 8 electrons. Example, lithium chloride. Particularly you can take here lithium. So around the lithium, one bond pair means 2 electrons present. Beryllium hydride. Beryllium hydride. Around beryllium, how many electrons are there? 4 electrons, less than 8. Electron deficient or incomplete octet. Boron trichloride or boron trifluoride. Around the boron, 6 electrons, less than 8 electrons, so electron deficient. Al Cl3, around the aluminum 6 electrons, less than 8 electrons, so it is electron deficient molecule. So these are the some examples. Around the central atom, particularly lithium, beryllium, boron, aluminum, we can consider around these elements less than 8 electrons are present. These are deficient molecules or incomplete octet. Now, moving to next exception or limitation. Odd electron molecules. Odd electron molecules. Now, octet rule means surrounding the atom 8 electrons are there. 8 means even number, but here odd electronic spaces. So definitely they do not obey octet rule even though they are stable. So in our syllabus, according to NCERT textbook, there are 2 examples, NO, NO2. How many examples? Only 2 examples, NO, NO2. They are odd electronic spaces, first example. Example 1. Nitric oxide. Valency electrons. Nitrogen group number 15th or 50A, 5 electrons, plus oxygen group number 16th or 60A, 6 electrons. Total, how many electrons? 11 electrons, 11 valence electrons. Now, its Lewis dot structure, how can we write? We can write like, once count, here 1, 2, 3, 3 lone pairs, 3 to the 6, 1 single electron, 7, 7 plus 2 bond pairs. 2 bond pairs means 4 electrons, 7 plus 4, 11, yes, correct. So here single electron is there now. That single electron you can write it nitrogen or you can write it oxygen, no problem. Okay, so odd electronic spaces means other than 8, even number, 8 octet, 8 even number. So it is exception. Now coming to example 2, nitrogen dioxide, NO2. NO2, valency electrons 1 into 5 plus 2 into oxygen group number 6, 17 valence electrons. Now we can write here so we can write like, yes, we can write like. Now once count electrons, definitely there will be 17 electrons. There are 17 electrons. Okay, 1, 2, 3, 4, 5. 5 lone pairs. So 5 lone pairs means 10 electrons. 3 bond pairs. 3 to the 6 electrons. Total 16. 1 single electron. How many total? 17 valence electrons. Understood? How many? 17 valence electrons. Odd number of electrons. So these are the exceptions. Now coming to third limitation or exception. So expanded octet molecules. Expanded octet or superoctet. Superoctet molecules. Expanded octet or superoctet molecules. Now, some examples are there. PCl5, SF6, IF7. These are the expanded octet or superoctet molecules. Around the central atom, more than 8 electrons present. More than 8 electrons. So they are expanded octet. More than, greater than 8 electrons around the central atom. Clear? So more than 8 electrons present around the central atom. Simply they are expanded octet molecules or superoctet molecules. So around the central atom, more than 8 electrons are present. So they are expanded or superacted molecules. Example, PCl5, phosphorus, 5 chlorine atoms are there. How many chlorine? 5. Around the phosphorus, how many electrons are there? 5 to the 10 electrons are there. More than 8 electrons. Example 2. SF6. Around the sulfur, 6 fluorine atoms are there. 6 fluorine atoms are there. 6 fluorine atoms. Now, 6 to the 12 electrons, more than 8 electrons. Now coming to IF7. Around the iodine, 7 fluorine atoms are there. How many fluorine atoms? 7 fluorine atoms. Now, 7 fluorine atoms means 7 bond pair, 7 to the 14 electrons, greater than 8 electrons. Now moving to next example, sulfuric acid. You can take sulfuric acid. This is given in NCERT textbook, very important. Here sulfur, simply you can write sulfuric acid structure. Yeah, this is the sulfuric acid structure. Around the sulfur, how many bond pairs are there? 6 bond pairs. 6 bond pairs means 6 to the 12 electrons. So 12 electrons means greater than 8 electrons. Expanded octet molecule. You can take orthophosphoric acid also, H3PO4. This one also we can take. Orthophosphoric acid. Okay, orthophosphoric acid. Around the phosphorus, how many bond pairs are there? 5. 5 to the 10 electrons. So greater than 8 electrons. These are all expanded octet molecules examples. Understood? Yes. Now, some other exceptions also there. Other drawbacks also there. So other exceptions. Some other exceptions or other drawbacks. Or other limitations. Usually, octet rule, it is generated from electronic configuration of noble gases. Is it right or not? So generally, octet rule, maybe it is generated or it is based upon the chemical inertness, means chemical stability of noble gases. Except helium, neon, argon, krypton, xenon, radon, around the all atoms, 8 electrons are there because their general electron configuration NH2 NP6. But some noble gases, particularly xenon, krypton, they also combine with oxygen and fluorine and forming some compounds. Means simply, xenon, krypton, even though they are noble gases, they are violating octet rule. That's why they are exceptions, they are drawbacks. I hope everyone understood this concept. Yes. So now, xenon can form some compounds with fluorine and oxygen. Xenon can form XeF2, XeF4, XeF6, XeOF4, XeO3, okay, XeO3, etc. Similarly, krypton can also form KrF2. So, usually this octet rule generated from electronic configuration of inert gases or noble gases. But those atoms only violating xenon krypton. Understood? So that's why this is one limitation, one drawback. Now, coming to second one. This theory, very, very important. This theory does not account for the shape of molecules. For the shape of molecules. Okay, simply this theory could not explain shape of molecules. Very, very important point. Okay, and it does not explain the relative stability of the molecules being totally silent about the energy of a molecule. Energy of a molecule. Okay, so very, very important. It does not explain the relative stability of the molecules. Being total silent about the energy of a molecule. Okay, clear? So simply it could not explain relative stability of the molecules. Generally, individually it can explain. So whether it is stable or not, individually it can explain. But relative stability means comparison it could not explain. For example, sulfur trioxide is there and some other molecule is there. It could not explain relative stability of both molecules. But of course, there are exceptions. Sulfur trioxide also exception. Around the sulfur, 6 bonds means 12 electrons. Okay, anyhow, two molecules, their stability, it could not compare. So which is greater stability, which is less stability, it could not explain. That is relative stability. Okay, relative stability means comparison, it could not explain. Understood? So these are very, very important exceptions. Clear? Very, very important exceptions. Directly, particularly NEET exam. Okay, for NEET examination, directly picking from these exceptions, directly asking from these exceptions. Clear? Even JEE mains advanced also very, very important. Okay, understood or not? So please once go through this lecture and please read number of times and try to understand this lecture. Very, very important. Thank you so much.